Let us solve another question which was given in GATE 2019. Here it goes. A certain processor deploys a single level cache. A cache block size is 8 words and the word size is 4 bytes. The memory system uses 60 MHz clock. To serve a cache miss, the memory controller first takes one cycle to accept the starting address of the block. Then it takes 3 cycles to fetch all the 8 words of the block, and finally transmits the words of the requested block at the rate of 1 word per cycle. The maximum bandwidth for the memory system when the program running on the processor issues a series of the read operations is dash into 10 power 6 bytes per second. Okay, here the question is about the memory bandwidth. Okay, okay. The memory bandwidth, there is a rule. What is the memory bandwidth rule? Number of bytes transferred divided by cycle time. This is the rule. So we need to find out what is the total number of bytes that are transferred. Let us have a look at how many bytes are actually transferred. Okay, so now just have a look at this. The clock is 60 megahertz clock. Okay, 1 megahertz is equal to 10 power 6. 60 megahertz is equal to 60 into 10 power 6. Okay, now we will see when we service a cache miss, the memory controller first takes one cycle to accept the starting address of the block. Okay, so you know that during a miss, the control will go to the main memory and the block will be accessed, rather the word will be accessed from the main memory and it will be fed to the CPU. And meanwhile, the same block will get transferred to the cache memory. Now he's talking about how this block will get transferred. Okay, so all it takes is, in order to get the starting address of the block, let us say this is the starting address. In order to get the starting address of the block, it will take 1 clock cycle. After which 3 clock cycles to fetch all the words. Okay, and that is 1 cycle to access the block, access the offset of the block. What is offset? Offset is the starting address. 1 cycle to access the offset of block. Then it requires 3 cycles to fetch all the 8 words. 3 cycles to fetch all the words of the block. All the words of the block. Okay, just 4 words are actually needed to go to the block and collect all the words. Just we have collected, we did not transfer it. Okay, but for transfer, the transfer will be done at 1 word per cycle. Okay, for 1 cycle there will be 1 word transfer. 1 word per cycle will get transferred. So the total number of cycles will be equal to 8. Okay, so 8 words will, in order to transfer 8 words, I require 8 cycles, because each word will take 1 cycle to transfer to the cache memory. So the total number of clock cycles are equal to 12, right? That is 1 to access the starting address of this block, 3 clock cycles required to fetch all the words, 8 clock cycles are required to transfer all the 8 words to the cache memory. Okay, total clock cycles is equal to total clock cycles is equal to 12 clock cycles. Okay. Now, 12 clock cycles will have a cycle time. What is the cycle time here? Cycle time is 60 megahertz, right? Okay. So that is cycle time will be, you know that T is equal to 1 by F. Okay. So what is the frequency? The frequency is equal to 60 into 10 power 6. 60 into 10 power 6. So 12 into 1 by 60 into 10 power 6. Okay. So total clock cycles is equal to 12. Cycle time is equal to 12 divided by 60 into 10 power 6. This is the cycle time. Now what is the memory bandwidth? Memory bandwidth is equal to number of bytes that are transferred. How many bytes are transferred? Total 8 words, right? 8 words are transferred. Each word is equal to 4 bytes as per the question. So 8 into 4, total 32 bytes transferred. 32 divided by the cycle time, that is 12 by 60 into 10 power 6. Because once again, just have a look at word size is equal to 8 words. The word size is equal to 4 bytes. So 8 words gets transferred. That means that 8 into 4, 32 bytes are actually transferred. Memory bandwidth is number of bytes transferred divided by cycle time. Okay, so that is 32 bytes by 12 divided by 60 into 10 power 6. Okay, now we need to calculate, that is 160 into 10 power 6 megahertz. This is the answer. 160 into 10 power 6 is the answer because we are asked about memory bandwidth. Okay, so here it will be 160 into 10 power 6 bytes. That is the memory bandwidth. Okay.